I'll need that.
Thank you, question 6. What did you do for?
Oh, I had. Cool. I can download your water sheet. Just 3 of them.
Sure.
What are you two doing?
The joy of learning.
Well, it sounds like you're having lots of fun there on the side.
Well, he was talking about his. He has the pedigree for question 6. I was like, perfect. I can just take that right out.
No.
Actually, do you want to go through that really fast? Make sure we have everything we need. Oh, and we're using the person taggler. That'll be easy. Oh.
Okay, without being stupid, doesn't everybody already have the pedigree for number 6?
Well, already typed into the Excel, so we could throw it through R.
In R, yeah.
But we have to use recursive tabular.
That's what he said?
Yes.
What? No, he didn't say so.
Yeah, using the recursive tabular method. He does say that. He's mean.
That took me forever to do.
Yeah, and I never quite did mine correct.
I finally got mine correct. Now I have to redo it with back
No.
crossing.
Read well. You say we did it in class, right?
Oh, yeah, okay.
Yeah.
Oh,
Yeah, we don't have to do the recursive.
Yeah,
Yeah.
no, he showed us how to use R. We can never go back.
Yeah, no kidding.
I was like, come on. Okay, so, okay. Because, yeah, we can at least, I can at least look at this.
I have a question on this one.
Okay. I'll mute it here for a second. Are you guys still working along, doing okay?
Yeah.
Perfect.
So I'm going to stop sharing and then upload it on Canvas, okay?
Okay.
Thank you.
Okay.
Thanks so much. Oh, Zach wanted a recording of office hours.
Well, technically they haven't started yet, but
That's true.
okay. Am I stupid, or did we not do the A, B, C, D, E, G, whatever? I thought we did.
For
For question
number 6.
Yeah, I thought we worked that out.
He went over a couple of them in class.
I thought, yeah, I guess I thought that we had to do that. Okay, no problem.
Yeah, no, so I had been trying to do it, and I know he said that a couple were off, right? So he posted that again, or was supposed to be.
Actually, he's changed the stuff here. He said if in this case he considered all the genotype as varieties, so it means they have high level of inbreeding.
Okay.
Yet
Yep.
before we are shown A, B, C, and D do not have inbreeding. Yeah, so that's what he has changed about mainly.
Okay.
Does that mean even E, F, G, H, and I are all inbreds?
Yep.
Okay.
All of them will be varieties.
So then you have to pull them in. And, yeah. Okay.
So that was like the soybean hint, because they're all just going to be,
Varieties, so it's giving to the level of inbreeding.
and they're all self-pollinating too. So you
Yep.
have to try really hard to get them to be anything other than what they are.
Yeah. What are we assuming? F9s? Okay.
Yeah, that's what I always actually use.
Okay.
Yeah, if he gives us the room to do that, I don't see why we shouldn't.
And, it's really not that difficult to do, so I feel so.
So I've posted it. You can access it now. Right. So
Yeah.
Let's find out.
Yep, I see it.
Yes, me as well.
Got it. Excellent job, guys. I just don't know if I can agree with Boris's naming the parents. XYUVMNKL.
You didn't like those?
Oh, I'm just teasing. I just thought it was funny in the last set of homework how Boris was worried about the heat map, and it was just because we had rearranged how the parents were laid out. And I'm like, yeah, that kind of stupid stuff will do it to me too.
And I noticed, I was like, man, why isn't my line 12 showing a relationship like theirs? And then I realized I put all the wrong lines. And then I put everything together because I misread the question. I was like, all the L lines, that won't fit in one Word document. And then I was like, oh, all the ones he listed, right, I got it. And then as soon as I did that, everything lined up. I was like, aha.
Yeah. Light bulb.
Ooh, darn.
Yeah, actually, I mean, that I like the fact that the way it's laid out, Boris, it actually does a good job of showing the relationship of everything, especially when you go to the XYF9 as the parent for A.
Mm-hmm.
Doing it in that way, that is good.
Good.
What's up, guys?
Kyle, who's this guy?
Yeah, it's been a little while. I fell off the wagon. I've been out there for a little bit. I'm back.
All right.
And we welcome you.
We have a party now. If we can really get out of hand before Dr. Beavis gets on here.
I haven't looked at the exam at all yet.
Perfect.
Honestly,
Jump on in with us. It sounds like a good time.
it seems like a pretty user-friendly exam so far, which makes me feel nervous because I don't know if that's hubris talking or truth.
Maybe you're getting better.
I want to believe that.
Go with that one. Stick with that.
I feel better. I don't know about you, but I feel better.
I've kind of gotten to the point of I just want to finish it and turn it in.
Yeah.
I just want my spring break.
I hear you. I'm kind of the same way for the whole kit and caboodle. If you guys want a happy thought, there are only 6 weeks of possible lecture left after this week.
But that last like 6 weeks for me is awful.
Really?
I'm buying a house and that whole process, and then I'm moving, and then all sorts of presentations.
What the heck? Are you like bored or something?
Masochist, probably.
Life just happens. It doesn't care what else is going on.
I thought I was crazy.
So I've been missing class here and there.
I suppose that's what it is. Kyle's like, you think you're nuts? Hold my beer. So where are you moving, Kyle?
Lyle, but moving to Boone. It's 15 minutes away from Ames.
Because you're bored, or?
I want to be in a house instead of an apartment.
It's understandable.
Mine is better. I don't disagree.
And my soon-to-be fiance would probably appreciate that.
Soon to be. Does she know this yet?
Yes. She knows.
She knows she's soon to be.
Yeah. I'm non-traditional. I can't keep anything from her.
That doesn't make you untraditional. That just makes you bad at keeping secrets.
That's what hurt.
I was going to say, I'm horrible at keeping secrets, too. I mean, like, horrendous. Christmas is a nightmare.
That'd be a tough secret to keep. It's like, oh, why are you being extra frugal right now? None of your business.
Yeah.
Why do we not have this much money? Don't worry about it.
It's fine.
Oh, it's not even that. It's kind of like, I bought you something today. Don't show me. Oh, but I want to. Yeah, it's that bad.
Are you trying?
Boy, not putting the right number in.
I was just checking it first.
Ah! What did I do? What did I do?
You know, making all kinds of amateur mistakes.
So have you guys started on the exam then?
Nope.
Okay.
Yeah, we're totally in on it, dude.
I don't feel that bad then.
Everybody wants to be done with this.
Oh yeah. I'm ready for this class to be over because then I'm done with the classes. Yay.
I am with you in that regard.
I'm just excited for this specific class to be done. I want to be able to like do things last minute on a Sunday and know I can.
Seriously.
Yeah.
Yes.
That's how I used to work. Now I have to do this stuff on Monday and Tuesday.
I have never spent this much time on a class ever.
Yeah, I think I'd agree.
Oh, I totally agree. And I thought class with Dr. Barb was rough.
Which class
No,
was that?
I think that was 520.
Oh, that's Farrah's replacement then.
Yep.
Yeah,
Not that she was bad, but that was a rough class. I mean, there was a lot in there.
See, with Farrah, it wasn't that bad. You just had to be ready for a little emotional abuse.
Well,
Yeah.
Jesus.
As long as you knew your stuff, though, you were fine. I'm not gonna lie, I'm reading over this exam, my mind is just glossed over.
It's okay. You can do it.
It gets better. I felt the same way Sunday when I first opened it.
Yeah. I didn't even look at it till Monday, and I just like slowly took some time to like read it and highlight it. Make some discussion posts so I'm participating.
yeah, if your brain hurts, mine hurts too.
Is it working for you? Mm-hmm. I don't know why I was having issue with this. So, what do you have?
Excuse me, sorry. Kind of a hiccup, kind of a burp. I don't really know what those are.
Oh,
Oh, I got all zeros. Perfect.
You know what?
Yeah, that's wrong.
Did anyone have their ALA 9 graded yet by any chance?
Not yet.
No.
nope.
Okay.
It seems
Yeah,
like
you know what that means, right?
Just wanted to make sure that I just didn't forget to attach it or something.
no. All I got was 8 and 10, I think, for this.
I kind of get the feeling that ALA 9 is going to be like ALA 6. We did something wrong.
That's kind of how I felt turning it in on a couple things.
Not gonna lie, I don't even remember which one 9 was.
Which makes me feel great about doing this test.
8 was 8 the bird assignment.
10 was the pretty pictures assignment. So, and so
Oh,
that was
yeah.
the 8 one.
yeah. So, and 8 was was the crap. I don't remember.
9 was
Writing.
the Dart assay one.
Yeah.
Oh, that's not good.
I don't remember doing that at all.
I felt like I actually really understood that one.
Yeah.
Questions very nice.
The independence of segregation. Whether they're in coupling phase or
Oh, that one.
yeah.
Yeah, I didn't know what I was doing. I kind of guessed.
I
Boy,
hit on a couple problems.
I was
Yeah,
like, mm,
what's the disequilibrium at the individual loci? Yeah, maybe we messed that up. I don't know. That's that RSTU.
yeah.
Yeah, okay, that's chi-square. I don't want to hurt my brain.
Yeah, I actually don't think I even calculated that to do this.
I don't think I did either.
I calculated that, and then I ended up doing a chi-square analysis at the end to get my answer anyway.
Maybe I didn't understand this.
I think there's a couple ways to go about it. Maybe it's one of those.
Do we need to understand it? Really?
Whoa, you can't just say that. I mean, no, you're right though.
I'm kind of at the point where, yeah, I like learning. I really do. I promise. But
Everything for you.
Here's a real rookie question. So for the null hypotheses, were you just saying that like it, there'd be two null hypotheses, one that the alleles for Bracino steroid are not in disequilibrium, and one that the genotypic frequency associated with lignin is not in disequilibrium, and that you prove it with a chi-square analysis?
Yeah, I think we were just planning on doing Hardy-Weinberg, saying the population is in Hardy-Weinberg equilibrium. But I guess you could probably just say that the loci or the alleles are not in disequilibrium or are not in disequilibrium.
That's what I said.
Are you talking about question 4?
1,
2B.
Question 2.
Question
C.
2.
2B.
Gotcha.
Yeah, I didn't say anything about Hardy-Weinberg because right in the question it says we don't know if they were random mated, so we can't.
So we can say we assume they're not in, or the null hypothesis that they're not in disequilibrium, and then the chi-square would
Yeah.
show. Okay,
That's
yeah,
what I'm thinking.
I agree with that.
Okay. Yeah, I'll just like pop what I typed just into the little chat window
Cool.
that's in Zoom. I guess I could have put it, where else I could put that is on the discussion board.
that would be awesome. That'd be
I'm
a
gonna do
great
that
place
right
to
now.
put that. Oh,
We're
that's
on the
amazing.
Zoom right now with everybody else.
Yes, you're going to join, right? Yeah, then we chat with you. Thanks.
Bill will be joining shortly.
Yay!
There we go, Boris.
More the merrier. Always a good thing.
Oh, you got it. Oh, you need to use this thing. This one. Yeah, this. To get the names on it.
Oh,
Straight up.
shoot. Yeah, you're right. So, FSSS, detach by CSV, so that's where we're heading.
Just like that. And then, columns.
Yeah.
Please share with me.
Yeah.
That I don't know when my hair has got issue here. It disturbed me the whole of Sunday, I'm telling you. Oh, good. So I think I'm going to start using my second computer now. Make sure I get things started.
Hello, everyone. How are you?
Hey,
All right.
Are there any questions I can help answer?
well, I guess I do have one question. Is ALA 9 in the same bucket as ALA 6 by any chance?
No, no,
Phew.
no. It just takes longer for me to grade that. I'm mostly done with it, but I just have to be careful when I grade it because people make different kinds of mistakes. So
Okay, awesome.
I expect it to be back to you guys either this evening or early tomorrow.
Okay. For the first question on the exam, is everyone kind of feels like progeny? So that the one about randomating canola and you don't have a marker, everyone kind of seems to be agreeing that progeny testing is the right answer. And I was just wondering if that sounds like we're on the right track or if we're maybe overlooking something.
Well, let's see. Oh, that's different. Oh, yeah, I'm just asking you, there's different ways of doing this, and how would you go about doing it? Just describe it, and there's nothing special. There's no
trick,
no hidden stuff in there. No.
I believe we were thinking of taking a subsample of each population and then random mating them and then determining how many were sterile and how many gave seeds, and then taking the ones that actually produced seed and then repeating that process with those seeds.
Right. Yeah. So there's some you have to recognize that. So this is the restore side of that. It's not the side that's already in the this Ogura CMS cytoplasm. Oh, there's a lowercase s there, be CMS capital S, but
We wouldn't want to cross them to test that, though, right? We would want to self and
Well, so you just know that this allele is segregating in this inside the restoration type cytoplasm. Oh, okay, but both these populations both exist in that cytoplasm. Okay, yeah, so that's the trick. That's the piece that you have to be careful about. So if both these populations exist in that cytoplasm, you have to, and it's random mating. How are you going to figure out the frequency of that restorer? There's nothing very hard about that. I think you may be making it harder than you need to.
Oh, I'm sure I am.
Yeah. So it's in the CMS cytoplasm, and it's segregating this RF allele. The restorer allele's in there, and all you have to do is figure out what's the frequency in that cytoplasm.
So what I was thinking about is taking those which are not fertile, count those, and then we expect those to have, how do we call it, Q square frequency. Then from there we can determine Q. I don't know if that's a good way of going about it.
Yeah, well, yeah, if you mean Q represents the frequency of the RF allele, yeah, that seems like the way to do it.
Okay, thank you. On question 6,
Yep.
we've just tried to get the coefficient of relationship using R, of course. So my question is about, like, what kind of statistical tests could we use to compare this coefficient with the one we got before using the recursive tabular methods?
Oh, I don't think you need to worry about a statistical test for a comparison. Comparisons don't necessarily give you the comparison. Okay, so you don't need any sort of statistical test on it.
Well, it's asking for a quantitative metric.
Yep.
What would that be?
No, you go ahead and come up with one if you want. Something that you can use to just say, okay, here's these set of values, and here's these other set of values, and are they the same? Are they independent? Are they correlated? Are they whatever?
Okay.
Okay, thank you.
Yeah.
So I think after that I have a question about
how do we calculate degrees of freedom for Hardy-Weinberg? I feel like it should be simple, but I'm not remembering.
actually it's about,
It depends on how many genotypic classes you have.
Okay.
yeah. So this is about question 2. So question 2B asks us to give a null hypothesis. So our hypothesis is that, okay, we assume these loci are in equilibrium or there is no disequilibrium. So
Yep.
we want to use chi-square to test it,
Okay.
expected versus observed.
Yep.
And then it's about the second table where we have 4 different alleles.
Yep.
So the question was, okay, in this case, if we have 4 alleles, should the degree of freedom be 3?
Good question. Yeah, I won't give you the answer, but I can have you think about it for a bit. You have with 4 different alleles, you have a certain number of genotypic classes.
Yep.
And those genotypic classes need to sum up to 1. And so you can figure out what the degrees of freedom are from that. Same way you do it for if you only have 3 genotypic classes.
Yeah, well, yeah, I remember in class last time we discussed and we had 3 genotypic classes, so I thought the degree of freedom was supposed to be 2,
Yeah,
but,
that's one.
but it was 1, yeah.
Yeah.
Okay.
Oh, why is
We'll
it?
think about it again and see.
Yeah, yeah, you have to remember that the sum of these things equals 1, so that ends up affecting how you calculate.
Okay.
Yep.
We're kind of boring tonight.
Yeah. So far I think
I don't know how much you can display.
Right. Yeah.
so. The only one that I think you may have trouble with, I mean, all the rest of these, you just have. I think you guys have seen something very much like the problem before. Is number 8. Maybe I'm reading too much into it. I think that one will be the one that you'll have to really think through how to do that, how to create your cluster diagram.
Oh, okay.
And I'm assuming for that a higher marker score means that they're more closely related, not having looked at the CSV file.
Right. Yeah, we need some kind of distance metric
Mm-hmm.
that you can feed into the R code, or have the R code calculate for you. When you know, in the past we had these continuous values, and we used a Euclidean distance for these G by E situation to cluster the lines or to cluster the environments. In this case here, I'm just asking you to cluster these individuals or lines, these lines, and then yeah, and they don't have some continuous value. They have A, C, T, and G.
Right.
My first.
So I'll tell you right away, Euclidean is not the right distance metric.
Oh, okay.
Okay, to help you out, A, C, T, and G are not continuous is not a continuous variable.
Okay. So we are trying to work on question 5.
Okay.
And it's kind of we are struggling. It seems to estimate disequilibrium is not quite easy as we thought. So we thought we should first focus on individual loci first to see if each loci is in equilibrium before going for pairwise.
Yes.
Okay.
Yeah, that's the same process of what ALA number 9 is.
Yeah, sure. Now, the problem is we don't know really how to get the estimate of the disequilibrium at each locus.
Well, so these came from a cross of 2 inbred lines, right?
Yes.
Yeah, and so so what is, if they started out as a cross of 2 inbred lines, what is the frequency of each of those alleles supposed to be?
1/2.
Yeah. Okay, and so if it's not 1/2, then why isn't it?
Okay. Then
Actually, the why, asking why isn't it, is, that's sort of, and there's a lot of reasons why it may not be. It's selection during the development of these things, or who knows. But the point is that if it's not, then you have some value for disequilibrium that is not equal. You have some value that deviates, and that deviation is deviation for the individual loci.
Okay.
And then once you've got that figured out, you can also figure out the disequilibrium between loci.
okay.
I think so. I'll have to pay a break here soon, but I think I know how to do it now. I think that was all our questions for now.
Okay.
I don't know if anybody else had any.
I'm sure I will later, but not now. Well,
Yeah, it's still a little bit early. So next week there won't be any class lecture discussions, right? And so because we're on break, and so if anybody's planning to go on vacation, that you still need to turn this thing in by Sunday. And let's see, was there anything? And then what I will do is the next set of applied learning activities, I may post them, but you don't have to deal with them next week. I just, if you want to have a couple of weeks to look at them at your leisure, go ahead and do that. I think that's probably the best way to do it. I'll post them as soon as I can, just so that, but they won't be due until the week after that. So after you come back from the spring break, there'll still be a full week to get them done. We're going to take our time on this this last section here. We still have to get through selection and heritability and that sort of thing, but we will take. So once we get back from spring break, I think there's like 5 or 6 weeks till the end of the semester. So we will probably only have a third exam. We won't have a fourth exam because I don't want to break this down into 2 3-week periods. Does that make sense? It's just the turnover is just too fast. So I'll probably only have a third exam and not a fourth exam.
Sounds good to me.
I was going to say, if you insist.
Yeah.
All right. Well, yeah, some people prefer to have more exams. Believe it or not. I've had classes that actually want more exams. I suppose it distributes any poor scores. But, and so on average, but on the other hand, you don't really have an opportunity to change things very much with one exam. So, and it certainly by that time of the year when everybody is really busy with planting and doing other field work, it gets to be a real burden to have to do that other exam. It's not a burden for me because I don't have any field work, but for a lot of the students, it can be a burden in May to be faced with or the end of April and getting to May to be faced with multiple exams. Okay, well, I'll let you go and see you tomorrow in class, unless there's something else that really needs to be dealt with.
I
Not
think
that I can think of. Thanks.
Sure thing. Bye-bye.
Have a good night.
Yep. Good night.
Thank you.
Is there?
All right, is everybody else still here?
Yup.
Big breath.
All righty. I actually think I'm gonna head home. Been here for a while, so I might hop back on. I might hop on tomorrow.
Yeah, I think I'm probably gonna start on this tomorrow. My brain is not really functioning today.
So I can hop on tomorrow too, and we can all help each other.
Yep.
Alrighty. Well, thanks for your guys' help so far.
Yep.
Thank
See
you.
guys.
Bye, guys.
Yeah, I caught that. I just was on the phone. So tomorrow night, when do we want to jump on? Any particular time?
I'll probably be on 5:30 to 6 or so, maybe.
Yeah, just like
Okay,
right
that's
after work.
Yeah. Yep.
I'll be on here like all today too, though. If I could have time to pack before bed on Thursday, that would be perfect.
I forgot it was daylight savings, so I just missed the whole office hours.
Well, he got on kind of late too, so you didn't miss a whole lot. Did anybody record it?
Did not.
All right. Well, Zach will just have to catch up. I didn't.
I think it'll be okay, though. There was only like kind of one major set of hints, and that was just like not using the Euclidean distance.
Yeah, that was a big help.
Yeah, I totally would have just used it blindly and been like, great, perfect, this is it. So for question, and I know we kind of talked about this already, but for question 2, so it would be 2 degrees of freedom then, since we have 3 experimental units for doing the chi-square.
Yeah.
I'm sorry, my brain is gone. I can't answer that question.
That's fine.
I'm looking at it.
Yeah, the other thing I'm confused about too, or not confused, but I'm just like not sure what probability to use. Because for calculating this chi-square, you need to know your degrees of freedom and your probability so you can plug it into that table.
Mm-hmm.
But like, should we just use 0.05?
Well, is that the confidence you want?
Oh, yeah. Yeah, like the cumulative probability or the confidence interval.
Sounds good to me.
And then the critical value. The cumulative probability is 1, but that doesn't really mean anything.
So which question is everyone on right now?
One.
One. Okay.
I'm just setting up my tables for 3 and 4. I just got done with doing 6.
Okay.
I am going through the calculations in 2 and then thinking about how to test the null hypothesis, like what response we're looking for.
Okay, that's where I was testing it.
Yeah, because like I'm trying to figure out the chi-square calculation and I'm being dumb and I should just go look at what I did in assignment 9 actually. But yeah, I'm like, what are the degrees of freedom and what's the probability and what's the cumulative probability? But why am I even using a chi-square if that's just test independence? And I'm going in some loops. I'm going some weird places.
Okay, that's where I was at also. So
Oh, good. Welcome.
at least we're still in the same problem. But yeah, I was still working through it.
I also kind of forgot about the second half of the question, so now I'm quickly going back and looking at those lignin values.
Oh, okay.
So I was like, why am I moving so fast? I'm like, oh, because I am forgetting things. But anyway.
I gotta jump off for a few minutes.
The help of others while I have it. I'm looking back at what I did for the... I'll share my screen. Oh, why did I make that red? Yeah, so this is assignment 9, and this is what I was doing to calculate the chi-square value based on like the calculation. And that's how I decided that there was or was not disequilibrium.
Okay. Yeah, so I was thinking, even in the file that Boris shared, he had already had that set up for the first population, right? The expected and the observed.
Yeah, and that's where I was getting, like, that it's set up, and then I was like, what happens now? Yeah, we have to make those numbers dance.
Yeah. Yeah, so I was working on it for the next or like the lignin population.
Mm.
All right. So have you done your chi-squared for the lignin population?
I have not.
Okay.
I also didn't realize I had the microphone on that whole time.
Did you do it, Michelle?
I was working on it. I was just debating because, like, I have the probability factored for just the 4 alleles. So when we break it back out and do the expected, should we be including anything that has that allele, or do we assume like a dominance or anything? Is what I was kind of debating.
That's a good question, and there goes my alarm, Justin.
Yeah, I was just reviewing my variance values, but I'm getting ones that are like a couple placeholders off from what Boris was getting, and I don't know why.
Oh.
Do not know why. He has 1.25. I have 0.00125.
I actually have the same thing as you, yeah.
Yeah, okay. And was this what Jacques mentioned, where it was just like a rounding thing?
I think so. I think it
How is
has.
it rounded if there's a, like, it must be, but how is there like a calculation to follow if it doesn't result in the same thing?
I think it's got to be a rounding thing because, like, he has to 4 decimal places in like the H column, and I do not.
Yeah, that just must be what it is.
Let's see if I change it, if it'd do that. No.
Okay, so I have that second chi-square table as well now.
Okay.
Yeah.
So did you do it just based off of the 4, or did you do it off of the observation since we have all 9?
I did it off of all of them. So I didn't group them together, but I could go back and change them. Just because
No, that's what I was.
value for each one. So rather than grouping the observations,
Mhm.
I left them that way.
Okay.
Although, let's look back at the question. Yeah, it doesn't say anything about dominance or anything, so the heterozygous state might have a value that we don't know that we would possibly want to consider individually.
Sure. Okay, so for like the variance component, you did it for just the 4. Right.
Yes, I did.
Okay. So then when you factored the expected, how did you do that for the 8 based off of the probability? Did you or like the observed, I guess, because like the expected, you just multiply it, the probability times the sum of the total population and get your what you'd expect. But then that's where I was debating with the observed. Do I count everything for the multiple alleles? Because then I came out to having a total of 47, which isn't right since there's only 40 in the population.
So I have like the genotype here. So I took the expected frequency from this table up here,
Mm-hmm.
and then the count as my observed.
Okay.
So I popped those into here, and then used the chi-square calculation to get this value.
Okay.
And it mirrors what was in that other table as well, and isn't like, you know, that really typical.
Yeah, but you shouldn't have 44, should you?
For the sum of these
The
values.
sum at the bottom. Yeah.
That's the sum of what the
I'm just looking at what you got, because I summed it all up and I've got 40. But my A, T, and T, yeah, I've got some different values than you do.
For which part?
For the chi-squared test. Although I have that as my expected. I'm sorry.
So,
hold on. Forget it. I'm looking at my expected table.
I'm just going to
stop. Just stop me right there. I made a boo-boo.
I was drawing a blank.
Don't mind me.
That's okay. This is like the one concept that I mastered. Just as chi-square is the one thing I've memorized.
Can you walk me through what you were just doing then? Now that I have to reorient myself.
Absolutely. So we need the genotype, the expected, the observed, and then the observed minus expected squared divided by expected. So to fill in
similar to question 1 there.
Yeah, exactly. Well, and it's kind of under the same umbrella, really.
Yeah.
Question 1. Do you just mean like?
Well, yeah, the B.
The other part of this question.
Yeah,
okay.
yeah. Sorry. Yeah.
Anyway, so.
I told you I'm tired.
Oh, it's okay. We've all been tired for a long time. I didn't put my genotypes together because there was no mention of dominance, and it just says that we're looking at lignin content, so there's nothing that indicates to me that this heterozygous genotype is not unique. So I left them separate. So the counts that they gave us are going to be the observed values down here. And then the expected frequencies that we calculated are going to be the expected.
Yep.
No, that makes sense. I was completely overlooking that I did that calculation. Because I was like, okay, how do I get this from the 4 to this?
And because last time, we didn't do that. We did it down here. So if you look at the previous example, and then it would have just been a matter of taking your variance, squaring it, and then timesing it by the total.
Yeah.
But we did that work here, so we don't have to do it again. And the work here was a little bit different because we have more complex things to consider.
That makes sense.
Yeah. And then figured out these values and then summed them to get this. So this total is going to be like our Z.
I love Canadians. You use Z.
I use them. It depends too, actually. Sometimes I say Z and sometimes I say Z. So I've watched enough American television that I just don't know how to pronounce or spell anything now.
I think that's frickin' fabulous.
Color with a U? I'm not sure. It depends if spell check will let me. Anyway, so now we have these values. And this is where I'm a little bit stumped, because if we go over into the assignment now, yeah, it's great that we have these tables, but what are we using to test? Because it's like, okay, so we got this Z value, but how does that Z value, what are we comparing it to decide if we're accepting or rejecting our null hypothesis?
No, that's an excellent point.
Because, like, in assignment 9, did I close that guy?
Can you guys explain where the expected value, where you got the expected value from?
Sure can. So, up here, the expected value, I'm going to escape because I have some stuff plugged in, is the expected frequency. So we have our gene frequency, and then we have our expected. So we're taking our variance and squaring it, and then timing it, multiplying it by the sum of what we actually observed.
Okay, thank you.
Yeah, so it is fair squared times obs total. And then we'll look at that again. Yeah. And it was a little bit different for some of them. So for this one, we were multiplying it by both A and T because it's heterozygous. So instead of squaring it, it was just 2 times each individual component of the genotype. Geno 1, whatever it is, Geno 2, whatever it is. And then whoop, by the observed total. And this is based on the work, like the expected frequencies here are based on the spreadsheet that Boris would have shared on the discussion page as well. So that's all there. But that's what I know. So anyway, looking back to my assignment 9, I don't know how you guys solved it. And I don't really, I kind of worked on it with Chelsea, so I don't really remember how we came to this conclusion completely. It made sense at the time. So yeah, we got this Z squared value. I just don't understand how we decided if it was or was not in disequilibrium.
Yeah, I'm trying to look back through that now too.
Mm-hmm.
Well, I hate to say this, but I think the answer comes from a song, which is, "Would you like to build a table?"
Oh no.
Okay, well, all we're trying to do is figure out is if they're in disequilibrium or not. Right?
Yes, that is what we are trying to figure out. Which is why it's like, why are we doing this guys for? Because yeah, in assignment 9. Yeah, go on your thought.
No, I'm just kind of walking through this a bit, going, if we just have to prove the disequilibrium, can we do that with the information we already have, the expectation versus the actual, the expected versus the observed, or do we need to go deeper than that? I'm only saying that because I could see him wanting us to maybe do a table, maybe with the brassinoids, but with the genotypes or the nucleotides dealing with the lignin, I don't think he wants us to go that deep as far as having to build a table, so it must be a little simpler. Just my thought process.
Test the null hypothesis for each of these loci in their respective populations. So we do need to test for each loci, which we did by doing this. And we get these big weird numbers. So I guess if we look at them, like in this first population, B11 is disproportionately represented. Maybe. I don't know what generation these are in. But if you
Maybe I should ask a different question real quick. So for 2A, estimate the variance for the estimated allele frequency within each of the populations. We've already done that. That's the VAR calculation, correct?
Yeah.
Okay.
1.97 and 1.92.
Yep. Wait, what? 1.972. I got the same for both of them in the first set.
Not 1.979 and 1.921.
Okay, I'm double checking because I think
I got the same values as you, Jacques.
No.
Okay, because I'm looking at Boris's, and I think he has the same as me. Yeah, he has the same that I do, and that does seem a little odd, but considering that the B1 allele is.
Yeah, I don't really know
the variation.
Followed his calculations.
Well, I mean, it makes sense. His calculations make sense, but I'm just saying that you're taking the allele frequency of B1, which is 0.0733338023. You're adding that to the genetic frequency of 0.05, cell C2 is what I've got. Then you're taking away 2 times the square of B7, the probability or the frequency of the allele, B1, and dividing that by 2 times the total number of samples to cover both alleles. Is that right?
Mm-hmm.
Okay, so that's for B1. And then for B dot, you do the same thing except you use the genetic frequency of C4, which is 0.9, and the allele frequency of 0.926666, blah, blah, blah. And you're getting two slightly different numbers, is that correct?
Mm-hmm. Not
Okay.
much, but a little bit.
That's weird. Wonder what mine would be. It just seems odd.
That's what I got. It's in the
Yeah,
little-
I don't blame you, but and Michelle, you said you got the same thing that Boris and I got.
Yeah.
I don't know why I have to be different. I don't know why I have to do this.
So anyhow, so the variation of the barasinoids we have, and then the variation in you have it's for A, T, C, and G. You did something like 0.0012, 0.0029. Does that sound right? For the second part?
Yeah.
0012, 0029, 0042, 0015.
Yes, that's
Okay.
identical to what I have for my variations,
Excellent.
which is weird because you were saying before that Boris's stuff is like off by times 100.
It
That's-
is.
Off by decimal places, like because I have 0.0012, but he would have 0.125 without the zeros.
This is the same with the 10 to the negative third or whatever.
Mm-hmm.
It would be the same as what we're getting.
Yeah.
Yeah,
Yeah,
those are
it
the
just-
same. They're just, he rounded them differently, I think.
Yeah.
Or not rounded them, but just,
So despite the finicky details, we got a bunch of numbers. What do they mean?
So, I mean, some of them, it looks like it's like what we're seeing versus what we're expecting aren't exactly right. So, I'm debating if it is enough to be in disequilibrium. I'm trying to find where we can calculate that exactly. Because, like, I was looking at the D equals, like, you multiply the probabilities and then subtract. There's an equation in the book.
Yeah, like when I do an image search, I'm seeing a lot of chi-square tables and stuff. Whereas like calculate the chi-square value and then have your n and then your p-value.
the null hypothesis about the frequency of the alleles is that they are not in disequilibrium, correct? That's what you guys are going with?
Yeah, because the null is that there's...
Yeah, there's no difference.
Yeah.
Maybe I'm just underthinking it, but when it says test the null hypothesis for each of these loci in their respective populations, and then I look at the work we've done, you have the expected and you have the observed, and you can sit and say, well, I expected 0.75 and I've got 0. I expected 3.575 or 4 if you want to round it up, and I got 1. And so on and so forth. And so from that, I would sit and say, my expected and my observed do not match, therefore they are not in equilibrium, and the null hypothesis is disproven. And that's how I'm looking at it.
Yeah, it might be worth tossing it on the board and seeing what other people think, and then just kind of leaving it till Thursday.
Yeah.
Because we could sit here and pull hairs forever.
Well, I mean, you have a great point. Okay, so we're getting these chi-squared values, but what do you do with them?
Why?
Yeah, I mean, Boris and Luke? Lyle did it for the brasinoids, but they didn't do it for the lignin. So I'm assuming that they've kind of sat and went, what the hell for?
Yeah, I'm gonna put that one in red for now, and then.
So that's just what I guess I'm gonna say.
Yeah. Do you want to toss that on that query on the board?
Sure, I'll do that.
And then we can see kind of what other folks are feeling.
Yep.
Cool. Anybody dabbled in question 3 yet?
Yeah, I've dabbled, but I don't have an answer yet.
Not yet. Just looking at it, I was a little more intimidated by this one.
Well, I like the way that Boris and Lyle handled it. I think the hard part's just getting the right number in the cells.
Yeah.
And I also like how they did I think it's the 4th question too, of making up their chart. Just while I'm typing stuff up, you guys can think hard thought, think great and wonderful thoughts. I don't know.
Yeah, I'm just like interpreting what they did on that table right now, trying to make sense of it. Not that it's like rocket science or anything, but. Oh, cool, fun, unstable loci. Woo!
Mm-hmm.
Determine the 3 different equilibrium values.
It's only in the wrong way.
So it looks like the table they have here is only for like recessive mutating to the other.
Well, we've got the values of the one switching over to the other.
Or oh no, okay.
Right.
V is little to big, and
Yep.
U is
Big to little.
big to little.
Yep.
And then we have Q and P values.
Yep. I'm not saying I can interpret all this right now, but I thought that the way that they handled it was pretty nice. Except I don't like this VU thing. Why not
Everyone has a favorite letter.
I know. I gotta have some sort of comment from the side. Yeah,
Determine the 3 different equilibrium values. So we have Q and P, but like, I don't know if those aren't the equilibrium value. I assume we have to, I don't know. Would we work those values into something else? Or would they just equal
Hey,
1?
Cassandra, how about this question real quick? What does the chi-squared value for each genotype tell us? Because it's comparing the expected for the observed. Is it, if it's under 1, it's relatively close to what it should be, and if it's over 1, then it's starting to deviate. But I thought there was something to that.
Yeah, so I'm just like looking at the sums of everything in combination. So our total chi-square value exceeds our observed and expected because they're equal because of how we calculate them. We calculate the expected based on the observed total.
Yeah.
So our statistic that we calculated exceeds in both cases, I think. In the first case, our test statistic is like half of the observed. It is dramatically lower. Whereas in the second scenario, our test statistic exceeds. And I'm guessing that let's go back and look at assignment 9. Whether we are exceeding or not is going to determine if we're accepting or rejecting. So in this situation, our observed was 105 and our test statistic was 50. So we said there was disequilibrium because it was less. It was much less in that case. So if we follow that logic, although I haven't gotten my marks back from 9.
Yeah, neither have I.
So if less means reject, or if less, oh shoot.
Well, all I'm saying is that it's a goodness of fit test. The chi-square test is a goodness of fit test.
Yes.
Are we fitting well? That's my question.
Yeah. So like, and I guess in these, you could say too that like for the first example, it is not fitting well. There is something wrong with this data. It is not behaving the way that we expect.
Okay. I'm just wondering if we wouldn't do the rust calculation. You know what I mean? I mean, that wouldn't make sense with all 9 of them, but
No. Well, and then the rust calculation basically just gives you numbers in the same way that we still have to ultimately figure out.
yeah, but the rust is the calculation of the disequilibrium.
Yeah. RU minus ST. So like for the last, or in assignment 9, when we used this, rust and the disequilibrium was 0.97.
You had 0.97, I had 0.097. Ooh.
I went further into the chi-square after. I was pretty not confident in that one, so.
Yeah, I'm not seeing
yeah,
that
I'm just
at
missing
all.
a 0 in that table. It is 0.978.
Okay.
Ha 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 ha.
Yeah, I had an estimated disequilibrium of 10%, 0.01, or 0.1.
Yeah, and this was the one where it was like, before you can prove if there's disequilibrium, you first have to prove that there is none. So we did that calculation. We got 0.97. I said, okay, well, that's 0.1%, you know.
Mm-hmm. Yeah,
Pretty low number.
0.01 per, or yeah.
Yeah,
There's a
because it
1%
could have just been
disequilibrium, yeah.
noise in the data. I said
Mhm.
this doesn't prove anything. They could be in disequilibrium. So then after that, once I proved that, then I did the chi-square to go further, to prove or disprove. And then because of the Z value being like 50, less than 50% of the original population, I said that there was disequilibrium. So in these cases, I would say that there is disequilibrium in the first case, and in the second case, there's probably no disequilibrium. That's just
You would say right now there's no disequilibrium.
not in the lignin locus, but I would say there is disequilibrium in the, what did he call that, the beta steroid or whatever?
Yeah, why would you say there isn't any in the lignin? Because some of those chi-square values get up high. Like the AG is, so you expected to see 2.5 and you got 10.
Well, I guess
That's
so.
what I'm
Like
asking.
40 divided by 44. Whoa, I just made my computer freak out. Why do you look that way?
Yeah, it says 0.9.
Yeah, 0.9. So it's 90%. Whereas in this case, it is 42%. And then in assignment 9, when I said there was disequilibrium, it was 50 divided by 105, which was 47%. So I guess it depends where you put your p-value, and I think that's, yeah, kind of the missing component is where you would look in your table and you'd say like, okay, this is how much error I'm willing to take. So 0.42 compared to whatever the test statistic is probably too low. Whereas
Yeah, maybe my brain's hurting here, but I'm trying to figure out why. I mean, if we have 40 expected values or 40 observations, and our chi-square is 44, isn't that just telling us how many? I mean, you're comparing the observations that we have versus what
versus the test statistic that we calculated.
Yeah, but how do you compare that with just the observations that we had? Because it's just 40. I suppose it's the sum of all the observations, and well, you can't get more than 40
Yeah, so that's where your error plays into it, I think. It's like, okay, this is over 4, but like, is there some error?
Well, I guess the brass, oh, I can't think of it either. The brasso-steroids is what I'm saying is that you have 2,800 roughly observations, and then your chi-square, you have a value of 1203. Well, how do you compare those two to sit and say, okay, I mean, does that mean we were expecting to see only 1,203 observations and we have more? Or, see, and what I'm getting at is I'm probably too stupid to figure out how you compare the observations to that chi-square sum.
I wouldn't say that it's stupid. I think that I have a very robotic understanding of this calculation where I don't really necessarily understand it, but I know how to plug it and pass it on a test. Or how to just like get the pass fail out of it. But that's why I think that we need to ask on the board like what other people are doing.
Yeah.
I'm not confident enough to submit this answer right now.
Sure. I'm just trying to wrap my head around it because we didn't cover chi-squares, or did we?
It was in the class notes.
Right. I know it was in the class notes, so but we didn't cover how to use it, did we? I mean, I don't remember him discussing it.
No, and it might be expected that we should just know it because it's generally covered in statistics courses, and like we would have done it in Dr. Fay's class and in your introductory genetics. And
Right. No, I'm still mulling around the whole idea of we've got this chi-square and how do we, because I would say that both of them are out just because of the observations and what was expected and what we saw for the lignin. I mean, you've got a number of them that are at 0 when there should be something. I don't know.
Yeah, well, it looks like, like for the G can occur in 4 different ways. It's only occurring in 2 cases. So there's probably, if you go back and look at it that way, why are these recombinations not occurring? Are they lethal? Is it impossible? Like, that's a good point.
Yeah, I think you're right. We're going to have to do degrees of freedom and significance level to find out our value. It makes sense, is what I'm getting at, what you've been discussing all night.
Yeah, well, and like what I looked up too, because I had to quickly Google it because I didn't remember all of it more. Because yeah, there's like even like an online calculator where it's like, okay, what are your degrees of freedom and what's your p-value that you're willing to work at, and from there.
Yep.
Yeah. I'm willing to leave that one until after even the office hours on Thursday and just kind of try and boogie through, get some like partial answers so that Thursday's more of like a fine-tuning day.
I'm happy with that answer.
Mm-hmm. So what the heck's going on in 3?
I don't know. 3 looks good the way that it's been calculated. Because the rate of mutation is the value that's given in each of the boxes, the value from small to big and big to small.
Yeah, that's kind of what I was seeing too. I just wasn't sure, and
then you calculate out your given those rates back and forth. You can calculate, your Q is in this case based on the how often do you get mutation back to Q, and then P is based on how often do you get mutation back to the dominant value, whatever. And because the rate of mutation in the first one, the population 1, the rate of mutation heavily favors going to the recessive allele, the small allele. The second population is at equilibrium. You have mutation going equally back and forth. And then in the last one, I believe it's much more favorable towards the small allele, but not in the same amount as the first one.
Yeah.
That makes sense?
It does.
I mean, that's what I'm seeing. I'm not sure if that answers. That's the different equilibrium values. That's my guess, is that those are the equilibrium values.
Mm-hmm. Yeah, and I don't know, really what more we need to say than that. I always struggle a little bit with this class where I, want to write something, but I guess numbers can just talk for themselves sometimes.
Yeah.
So that might just be it for that.
I mean, that's all I'm seeing right now.
Yeah, are you checking?
Sorry, just got notice from my son. The basketball team finally lost.
Oh, no. They had a darn good run.
Yeah. No, that's fine. It's actually better because now when we go to New York, he won't be regretting not being around for Boise State basketball.
Fair enough. Yeah. Anyway, were you looking at literature on quote unquote literature online, or were you looking at the class notes
for
the disequilibrium stuff?
Oh, for question 3 or?
Yeah, for 3. The one we were.
No, I was just looking. Actually, I was just looking at the numbers, just intuitively. I'm just looking at. I'm looking at the first one, and I'm like, well, obviously the first population, 1 times 10 to the -7 is a much smaller number than 4 times 10 to the -4. So it's going to heavily skew towards the small d allele, the dwarf allele, whatever, the non-dominant allele. The second one, it's exactly the same mutation rate. So they're in equilibrium at 0.5.
Sounds good to me. For question 4, all I wrote when I went through it last night was, is this based on the assignment we all did bad on?
I was thinking that too.
I was like, oh, okay, good. Yeah, this is the one he didn't even want to give us marks for. Sweet. But it looks like we got a nice little year by or what is this table? So it's like generation. And then what's the 1 through 11 value?
What are you looking at?
What Boris had for question 4. Trying to put some headings on it, but
oh, it looks like the number 1 is the generation it's at now, and then down to 11 takes it to the 10th generation.
So it's generation on one column and then time on the other.
Yeah. 0 through 11, I believe, is in years, and then across the top is allele frequency.
Yeah, because we're looking, determine the frequency of the undesirable little a lignin allele after 2, 5, and 10 generations of selection.
Oh yeah, and that'd be selection pressure, I'm guessing. And it's Q. Q is the first column, and P is the second column. And P is dominant A. Yep, P would be dominant A. I bet he did that to double check. That makes sense now that there'd be a little Q there?
Mm-hmm. Yeah. So we have a table of Q values and a table of P values.
Yep. Because I just did the Q value at 0.2 selection intensity for the 11 row, adding up the Q value and the P value, and they come out to 1. So I'm guessing it would be the same across the whole thing. So The p-value, of course, is the selection intensity is 0.8 versus 0.2, or the frequency of the allele is, I'm not sure, I'm guessing that would be selection pressure against Q is 0.8. Our selection of P at 0.8 would be, I'm not sure how to interpret those numbers across the top is what I'm saying. I'm assuming it's selection pressure.
I buy it.
Well, the problem I have with it is that if you have a 0.2 and a 0.2 Q, you actually get quite a dramatic drop. If you have a 0.8 Q, you get a pretty anemic change. I mean, it's 0.38 to 0.37. It's kind of 0.38 the whole time.
Mm-hmm.
And I'm not 100% sure how the heck that's calculated itself. Because it doesn't seem quite right. What I'm saying is that it's year one. When you go into that 0.2 year one box that has a value of 0.309, it's referencing the year of 1, x9 in this case, and then the selection intensity. But when you go to the next one, it's going with the box next. I'm just not sure that formula is set up correctly at this point. Oh crap! I never did.
Off of the population, right? I'm just going off of population 4 would be square root of little a, which would 0.2, population 5, square root of little a is 0.5, yeah, and then the 0.8 is square root of population 6 little a. Until he's getting Q.
I'm sorry, what did I miss?
Um,
I heard Tiffany talking, I believe.
I was just trying to figure out where he got those Q numbers from, but it looks like it's the square root of the little a for whatever population. So, because there's population 4, 5, and 6, right?
Yes.
mhm.
Okay, so I was just trying to figure out where he got that Q value. That makes sense.
Oh, okay, that makes sense. You're right. I agree.
And then his P is just 1 minus that. And then he went by year.
Yeah, I'm just wondering about that number is what I'm saying. If you look at his first formula, he's referencing cell X9, and that's just the year number. But if you go in for the 0.2 column, but if you go over to the next column, then he's referencing the 0.2 column instead.
Right. That probably should be the 0.5 column.
Well, I'm not sure for that first one, the Z9 or Y9 or X9, if you should be referencing well, I'm guessing it's the number of cycles of selection, isn't it? But that doesn't quite, I don't know.
Yeah, sorry, I've been in and out. I was thinking it was off the generation, so like it would be 3 different generations that he's working on, but that pretty much just goes in consecutive order, not necessarily like, it's not jumping cycles, like it'll be like F2, F3, F4, isn't that kind of how it's calculating? If you're working off of one population?
Yeah, I think we need to ask Boris a question of what went on here, because I think that the second and third, the 0.5 and 0.8 columns are not being calculated correctly.
Yeah.
I'm guessing they should be.
Yeah, because otherwise it looks like you're just working off of the previous generation, basically, in this.
Yeah, well, you're not, and it's not even supposed to be that. It's a different population.
Yeah.
The 0.2 is population 1, and then 0.5 is population 2.
Yeah.
Yeah, might be worth putting again, just like a comment on the discussion board, because they'll probably have time to look at it during the day, and then might get back to it before tomorrow evening when people meet up again. Because everyone's on the mad dash to do this by Friday, so. Which is a great mad dash. I'm super into it, but.
Oh, and the other thing is, well, let me take a look and see how he set that up. Okay, maybe it looks like he set it up right. Yeah, okay, I'm kind of getting the feeling for what he did, because we're just looking for the frequency of the A allele.
Determine the frequency of the little allele after generations of recessive selection.
Yeah, the only thing that we're missing is he isn't taking into account the heterozygote. Unless I'm wrong, and that may be. Because that's the frequency is the frequency for the homozygote, but not the heterozygote.
I think it's the frequency. I think it's the frequency of the allele though, because he's squared. It'd be Q squared, right? Would be the frequency of that allele.
Yeah, but only squaring is the frequency of the homozygote. There's nothing in there that's taking into account the heterozygote. Or am I?
I don't think you need to.
I'm picking up what you're putting down.
Yeah. It's getting to be 8 o'clock, and my brain's kind of melting out of my head, I think.
Oh yeah, everyone's in a different time zone than me now. We don't change time zones here. We don't do daylight savings time in Saskatchewan.
Right.
Yeah.
Because we believe in simplicity.
Yeah, I can go with that.
Yeah.
But yeah, I don't understand why it goes off the previous population and always going back to the 0.2.
Well, I think I figured out 4, but I'm not exactly sure why.
What'd you get?
I'll just share it. So I'm following along with what Lyle and Boris were working on. So again, here's the square root of the frequency of the recessive, because we're just getting rid of the recessive homozygote from what I'm reading in the question. We're getting rid of the recessive allele over selection. Doesn't say any, I suppose I'll put in there the assumption is we can only get rid of the recessive as we see it. And we can't test for the homozygote or heterozygote. And then with this, what I'm seeing is you're taking the year of selection and you are adding that year to the square root of the frequency. So 1 divided by the square root of the frequency. I'm not 100% sure how that all works out. 1 divided by the year plus 1 divided by the square root of the frequency of the allele gives you that number. And then as time goes on, it reduces. But essentially in the first year, it seems to increase and then decrease. Or this is where I'm kind of lost in here with what does all this come out to, other than after so many years of selection, you get that. I've got to work on my understanding and figuring that out. And then this is just the opposite, the reverse of it.
Yeah. That's what I'm thinking too. I also don't really understand that calculation.
Yeah. I mean, it just seems like it's the frequency of the allele A for each population after 2, 5, and 10 generations, which is fine, by elimination of recessive genotypes. Okay, there you go, recessive genotypes. So the recessive homozygotes would be removed each year. I just don't know why 1 gets a bigger number at that 0.3. That's all.
I was talking to myself. Like a lot.
Say it to us, Cassandra. Repeat it again.
No, well, I don't really remember all of it now, but it's funny how, like, as I was talking to myself, you guys were answering my questions anyway.
Oh, well, that's always fun.
Yeah, well, I could have went on forever. Anyway, yeah, like, it makes sense that it's an inverse, because that's why the columns are backwards. Again.
Mm-hmm.
Yeah, if we're just moving recessives, then that would explain why we're not paying attention to heterozygotes.
Yep, but I'm wondering why the calculation is set up the way that it is, instead of it just being like, if the frequency is 0.04, why not say that, in each generation, roughly, and it's at equilibrium, 1/4 of the population should be homozygous recessive, and then you remove it. So wouldn't you just get rid of, maybe that doesn't work, 3/4 of the population each time, but it's not 3/4.
Yeah.
Because the allele is slowly going to fade out. It's a question I'd like to have answered. How do we figure that out? Or at least I'd like to ask Boris how he figured it out.
Mm-hmm.
And the reason I'm saying that is because at the first year, the frequency seems to go up to 0.3. Well, why would the frequency increase after the first year of selection?
Is it showing up because it's the first generation, whereas it wouldn't be obvious in the F1 because everything's going to be homozygous, so the recessive isn't going to be evident?
You may be right.
Like you can't do selection on an F1.
I wasn't thinking that was an F1. I was thinking it was year one, but not of a cross. But because of the way that it's stated in the question is that populations 4, 5, and 6 are in equilibrium. So you've got an equilibrium of the population, and now you're going to just go in and ruin it all by starting to whack out all the homozygous recessive.
True enough, there's no indication. I was just thinking because of like at work, just doing work, I'm always starting with that. So I'm like, oh, that would explain why it would show up, but not.
Yeah. So that's something I want to, something I need an explanation.
Something for the discussion board?
I don't know if it's a discussion board thing or not. I need to know the proper formula for determining, you get rid of 0.04 out of the first year's population, that frequency of the A allele should drop. And maybe it is, but I mean, even if you look at it the way, 0.04 plus 125 is still not 0.3.
Yeah.
I'm trying to figure out how you get that first initial 0.3. I want to make sure the calculation's right. Why is that all the way down here? Oh. Just gonna write a note for myself. I'm pretty close to piecing out here.
Yeah, well, like to get through this assignment, doing 3 questions a day, Tuesday, Wednesday, Thursday.
Yeah, but we're already a dang far way down to 6.
Yeah, we're pretty much done 1. I just have to like edit it. Question 2's pretty much done. Just have like some tweaking.
Yep.
Question 3. Pretty much done. 4, again, just some tweaking. So that's 4 out of 9. And Boris was so generous to share this data and already has the parental data for 6 ready.
Yeah, you've got part of 2 done. You don't have the last part of 2 done, do you? Or did you?
No, that's why I said it still needs some tweaking.
Yeah, 2C. Okay. So long as you didn't figure something out and then keep it back.
No, I have to be generous with anything I figure out because you guys help me more than I help you.
Oh no, we're all in this together equally, trust me.
Yeah, I started looking at the data set for 5 and it was scary. It's like the first question we actually need one of the exam data sets for. And I just, kind of shut down a little bit.
Yeah, 5. I'm tired. My brain ain't working on that.
Yeah, I'm cool with calling it a night and knowing that I'm just gonna have to come back.
Yeah. How about you, Michelle? You in on, or Tiffany? Either one of you?
Yeah. If you guys go on tomorrow, do you guys mind recording it? Because I probably can't go on tomorrow, but I'll be back on Thursday.
Yeah, I'll be back.
I have no idea how to do that, and I don't have the software to do it.
I don't know how to either.
I think. Well, Lawrence is on right now, and he's been posting stuff, so maybe he'll have it.
Okay.
Well, now see if anybody else is on that can do that, like Zach or Kyle.
They've got the power.
They do have the power.
Yeah, I'll plan to
Alright.
be on tomorrow night and less distracted than tonight.
Cool.
And less distracted. Oh, okay.
I'll be honest, the Bachelor finale's on right now.
Ah,
I'm
well.
sorry.
Oh
Priorities.
no! Come on, guys. We're. This is Tuesday night, and we're tearing into this. I'm impressed.
I'm very impressed by us. We're such good students. Dr. Beavis must be so proud to have us.
We'll see.
I'm
I hope so, but
I'm gonna go to bed with that glove sense of winning. What I'm gonna take with me. Okay, well, I will see you guys tomorrow at. I might be a little bit late because of the time change, but
whatever works.
all right.
Talk.
See ya.
Yep, have a good night.
You too.
Have a good night.